The Energy Warden Policy module is a web-based system for monitoring the real-time in-situ performance of different renewable energy devices installed in a building. These are photovoltaic, wind turbine, solar thermal, and geothermal devices. The Energy Warden Policy module monitors also the performance of the building as a whole in terms of CO2 emissions. The Energy Warden Policy tool functionality is based on existing international performance standards. These standards have been appropriately adapted for in-situ monitoring since they are usually meant for laboratory use. The user should first register his product by inserting the name, contact details, company name, the product serial number, if it is available, and the password. Then the user should log into the account. In order to monitor performance and various other operating parameters of the new system, either photovoltaic, wind turbine, solar thermal, or geothermal, initially the user should press the plant configuration button in order to import the plant data. Select the power plant type from the drop-down menu. There are 4 options: photovoltaic, wind turbine, solar thermal, and geothermal. Then press the New Plant button and insert the requested data. When you are finished with the plant configuration data, by pressing the button Sensor Data Import, the installed system should be selected from the drop-down menu and the sensor data will be uploaded and imported to the database automatically. It should be pointed out that the Energy Warden Policy module can plot a wide range of different charts. For example, area charts, bar charts, column charts, line charts, and 3D charts. Moreover, the Energy Warden Policy module can plot results for 3 different preselected periods: 7, 30, and 365 days. Also, there is the option of showing all the available data by selecting the option All Available Data. Finally, a specified period of time can be manually selected using the option Data Range. The Energy Warden Policy Wind Turbine Performance module determines the wind turbine power performance characteristics by the measured power curve and the estimated annual energy production. The measured power curve is determined by collecting simultaneous measurements of wind speed and power output. The annual energy production is calculated by applying the measured power curve to reference wind speed frequency distribution. Initially, the location of the system should be inserted. Then we proceed with the data input. These are the system power, the CO2 avoided and CO2 conversion factors, the swept area, the output type AC or DC, the generated voltage, the cut-in and cut-out wind speed, and the average site air density. The sensor data should then be imported. With the correct power plant type and the examined plant specified, select the type of sensor from the Select Sensor drop-down menu so that all measured values from sensors that are needed for the performance calculations are uploaded to the Energy Warden Policy module. The types of sensors available in the case of the Nicosia test are ambient temperature, barometric pressure, power output, wind direction, and wind speed. After the sensor data is imported, the graphs of the plant operation and performance can be plotted by selecting the Performance Monitoring tab and specifying the measured or calculated values to be plotted, the plot period in the Plot Period drop-down menu, and the type of chart preferences, e.g. area chart, bar chart, column chart, line chart, and 3D chart. The measured values are the following: the wind speed, which is the normalized and averaged wind speed in meters per second, the wind direction in degrees, the ambient temperature in degrees C, the barometric pressure in Pascal, and the power output in kilowatts. The calculated values include measured power curve in kilowatts determined by applying the method of bins for the normalized data sets and by calculation of the mean values of the normalized wind speed and normalized power output for each wind speed. The measured annual energy production in kilowatt hours generic annual energy production is estimated by applying the measured power curve to different reference wind speed frequency distributions. The extrapolated annual energy production in kilowatt hours extrapolated from the maximum complete measured wind speed up to cut-out wind speed. The power coefficient, which is the ratio of the measured power and the wind available power, and the planned CO2 avoided, which is the carbon emission savings. By pressing the reporting button, a full report of the results can be printed. Thank you for your attention.